time ever, astronomers might have witnessed a star actually become a black hole right before our eyes, or telescopes. In this visible light image from the Hubble Space Telescope, we can see a large star about 25 times the mass of our Sun, around 22 million light-years away in the galaxy NGC 6946. This was in 2007. But in a Hubble image from 2015, looking with the same filters at the same wavelengths, the star appears to be gone. One possible explanation? The star died and became a black hole. But it gets weirder. The most prevalent theory for how a black hole forms is through a supernova. If a star is big enough, at the end of its life it will eject its outer layers at high velocity in a massive explosion, while the inner core collapses into a very tiny space, creating a gravity well so great that light can't escape. Literally a black hole. So did we see the star go supernova? No, not really. A team of astronomers was monitoring the star with a large binocular telescope in Arizona and saw the star get brighter in 2009, but not nearly as bright as a supernova. They call it a failed supernova. The star does expel its outermost layer, but relatively gently and not in a big explosion. Okay, so the star got brighter in visible light in 2009 and then disappeared in visible light. How do we know it's not just hidden behind a cloud of dust or something? The team checked for that. They looked at infrared observations from the Spitzer Space Telescope, which would be able to see the heat of dust warmed by the star. What we see with Spitzer is there is some emission in the mid-infrared, but it's fading and fainter than what you would expect to see with a hidden star. The team thinks instead that this infrared light is from the heat of gas falling back onto the newly formed black hole. To help confirm that the star is now a black hole, the team plans to analyze the observations taken with the Chandra X-ray Observatory, which would be able to reveal X-rays being emitted by the gas falling into the black hole. The team also wants to continue monitoring the star's location in visible light with Hubble, in case the star is still there and reappears. And they'll want to look at the location with the upcoming James Webb Space Telescope to check if there's a surviving star hidden by cooler dust than can be observed with Spitzer.
Deep in the heart of the spiral Milky Way galaxy, a hot vortex of matter swirls around a black hole more than 1,000,000 times as massive as the Sun. Many galaxies, perhaps all, contain such a monster in the middle. These supermassive black holes sustain themselves by swallowing stars, planets, asteroids, comets, and clouds of gas that wander by the crowded galactic core.
astronomers introduced a new analysis technique that for the first time allows them to peer deep into the gravitational well of a normally quiescent black hole. Called X-ray reverberation mapping, the method charts the region close to the black hole using light echoes from X-ray flashes, similar to the way sonar uses sound to map the ocean floor.
X-ray reverberation mapping has been very successful at probing the accretion flow in well-established accretion disk structures, but had never been used to look at tidal disruption events. My collaborator at the University of Maryland and I were having lunch one day, and she says, "Has anyone ever looked at tidal disruption events with X-ray reverberation mapping?" That night I stayed late at the office and just tried it out on this data from Swift J1644, and much to my surprise, the result was amazing, and I could see that we were looking at the structure of the inner accretion flow around a normally dormant black hole for the first time. It's not like a normal accretion flow in an active galaxy that's a flat disk. This is something that is extremely puffy, very turbulent, and we are measuring flashes of X-ray emission deep within this newly formed accretion disk.
Stellar material streamed into the developing disk, churning it into a thick, chaotic whirlpool of X-ray emitting gas, funneling toward the central black hole. Deep inside this cavity, multiple X-ray flares erupted, providing a flash that echoed throughout the region.
Previously, astronomers had thought that the X-ray emission is coming from far out in a jet. But what we're finding with these observations is that the X-ray emission is coming from flares very close to the supermassive black hole. And we can use these observations to probe properties of the black hole itself. For instance, we found that the mass of the black hole is something on the order of 1,000,000 times the mass of the Sun.
The first observations of X-ray reverberations from deep inside an accretion disk are providing new insights into a rarely observed class of black holes. They're also laying the groundwork for a better understanding of tidal disruption events and the black holes they illuminate.